So from today onwards, we're going to be kicking off the Spark fundamentals. And after Hadoop and Hive, where the most of the processing is being done in the big data ecosystem is the Spark. That is what used in most of the projects. So how it is different than Hive and in the previous version and the orthodox and the obsolete processing ecosystem, that was the MapReduce. So previously the MapReduce there was a hell lot of boilerplate code with that we had to deal with. First of all, there was not only one single module or class. First of all, MapReduce only used to come with Java, and there was no option for Python or Scala or anything. And second thing is that MapReduce, for MapReduce, writing a single hello world or writing a single word count program, so it used to take at least 3 classes that we have to write. One is the driver classes, then there's the mapper classes, and then there's the reducer classes. There were so many complexities, and there were so many complexities, and then there were so many uh, uh, it's so much of tediousness. So that is the reason we moved to Spark. And there's one big reason why Spark is much faster and much efficient than MapReduce, because MapReduce, there was the concept of computation using the disk, whereas in Spark, it's totally in-memory computation. Okay, so what does it mean? Is that in MapReduce, the intermediate data, whatever we process, so that used to be kept in disk, and from disk, it was read back again in the MapReduce process. Whereas in Spark, the in-memory means the RAM. Okay, so there is a significant difference between the hard disk and the RAM. In hard disk, you store your data, be it like a media file or document or anything. But the fact of the matter is, suppose how RAM works is you're opening too many applications at the same time, right? You're having your browser, probably you're watching a movie in a VLC media player app, or probably you have some other application open at the same time. So uh, all these tasks are being allocated some portion in your RAM. Okay, if you see the task manager, you see some of the application have been hogging much of the RAMs, the other not so much. So that's basically the in-memory processing that the computer is making. So that's how the RAM works. And in Spark also, whatever the data processing happens, the intermediate result and everything, they keep it in the RAM only. So that's why it's much faster for it to read from the intermediate result and everything, and then give it back to the driver program. Okay, so this is the reason why Spark is much faster and efficient than MapReduce. The second thing comes, which is the which is much like the Hadoop ecosystem. Spark has this semi-master slave architecture. So when I say master slave architecture over here, the driver program, Spark does have a driver program, and it also has the workers, or so to speak, the executors. Okay, so how does it work? That whenever we write a code in Spark, okay, so that is known as the Spark application. Okay, that's not a Spark job. So there is this misconception that my Spark job is running. No, actually my Spark application is running. And inside one Spark application, there would be a lot of jobs. And then they will be broken down into stages and tasks. I will come to that later, how that happens. But first and foremost thing, when we write a Spark application, when we submit a Spark application in Hadoop Yarn, or suppose in AWS EMR, or the newer platforms, that is Kubernetes and whatnot. So what happens that there is the initial driver program, which is much like the entry point. Okay, that is running in your cluster, and where that driver will be running, Apache Yarn is there to maintain that. Okay, that will allocate some resources. Based on that, the application master will take the driver and make it and initiate the driver program in one of the nodes. Okay, from there on, the driver's job is to spawn the executors or the workers in different other nodes in the cluster. Okay, so if you look at this diagram, this driver having the Spark context, this was the older version, now is the Spark session. Okay, for the that comes with the data frame API. So with the Spark session, this driver program will simply spawn the executors in different workers, or that is known as the different nodes in the node manager, right? In the year, and I was telling you that there was the resource manager, which will allocate the resources into different nodes, and then node manager will simply run in its own container when the driver needs it. Okay, so that's how each and every different nodes in the cluster, so the workers will spawn its executor. And if you see inside the executor, there are different tasks. Okay, so what does this task mean? Is when you submit your application, or suppose in simple terms, you have a file or data in Hadoop and you're reading it through Spark. So Spark will create some partitions. As soon as the data reading is complete from the Hadoop, Spark will create some partitions out of it. And how does it do? How does it do? So basically, I've told you, right? In Hadoop, there's a block size called 128 MB by default, and for newer version, it is 256 MB. Similarly, if the data is in S3, S3 also has this block size concept. Okay, much like 128 MB or something like that. So be it S3 or be it Hadoop. So based on the block size, Spark will create the partition, that is the file size divided by the block size. So initial number of partitions when the data is read into Spark, that will be equal to the file size divided by block size. So if it is 1 GB of file and the block size is 128 MB, so roughly 10 partitions will be created. And each and every partition will be taken upon by each and every task in the executor. Okay. And this task is nothing but equivalent to the number of vCores or the virtual cores that I assign. Okay, I mean the executor cores. So how does it happen? Suppose I have a cluster of say 10 nodes, and each and every node, so I assign the parameters, right? Executor cores, then there's num executors. So my executor cores, have you heard about these parameters or you're totally new to it?
Totally new.
Totally new, right? Okay, so this is how a Spark submit command looks like. Okay. So when I have my, so suppose this is the pyspark.testpy is my Python module where I have written the code. Okay. And this is how I'm going to submit my Spark job into the cluster. So that is Spark, then hyphen submit. Then I am providing driver memory. Driver memory, as I'm saying, that how much memory, how much allocation that's the driver program needs. Usually it's less than the executor because driver only needs to initiate the whole process to spawn the executors. So it's usually much less than the executor, but depends on different scenarios. We might have to give it some more memory to driver memory. What are those scenarios? I'll come to that later. So one is the driver memory. Then second is the executor memory. Executor memory that will be transferred to these executor that are working in the worker nodes. Okay, that are kind of like the slave components. So we assign the executor memory, and what is the optimum amount of memory we should give. All these things we'll discuss later, but just on high level overview, just know this thing. One is the driver memory, then there's the executor memory, then there's the number of executors. Okay, so executor memory is in each and every executor, the amount of memory I'm allocating. So each and every memory over here, I'm allocating only 2 GB. Okay, number of executors is how many executors I want to spawn in the cluster. Okay, so in any worker node or any node, there could be one executor, there could be 3 executors, there could be 4 executors. Okay, not necessarily in one node there will be one executor. Fine. So the thing is, I can assign that number. How many number of executor do I want? Okay, and after that, my Python module where I have written the code, and this is just a command line argument. I mean, I was testing one of my scripts, so this is just one of the arguments that this script is. This is totally optional. Okay, for my case, it was needed, so I'm going to remove it for the moment. Okay, and there are some other components as well. We'll discuss about that later going on, but these are the some basic thing. And also over here, we need to put the master. Master is where my Spark application will run. Okay, in Yarn, sorry, in EMR or in Hadoop, mostly Yarn will take care of it. But I may have some Kubernetes cluster as well. So that is some Docker thing which is totally out of context. Okay, for those cases it is different. But usually in mostly use cases, I'll be submitting my Spark application in Yarn. So that is what I have to decide over here. That is what I have to assign over here. In fact, inside the code as well, I can assign the master. But if I run the code in my local, in that case, in my local laptop, there is no Yarn. So in that case, I'll be putting master is local only. Right. So, so where was I? Okay, so these are the components that I use. And in my cluster, suppose I am putting over here 5 executor, and I'm giving say 5G RAM to each and every executor. So there's total memory being allocated to my Spark job is 5 into 5, that is 25 GB. For each and every executor, there will be 5 GB allocated. Okay, and there are total 5 executors that I'm using to submit my Spark application. So total 5 into 5, 25 GB of memory has been assigned for the executors only. And for the driver, there's only one driver will be running. Okay, there's no like number of drivers or anything. There's always one master, one driver. That is usually we give in the real-time scenario like around 5 GB. Over here in my local, I was giving 1 GB. You have
Okay.
any question about this?
Yeah. So what is this command exactly doing? Are we trying to allocate some memory to the program that we're going to run?
So this is, first of all, it is basically running the Spark application. Okay. Or in layman terms, if I talk about Spark job. So in the cluster, I have to submit the Spark application in order to make it run. Okay. So my Spark job, the code that I've written is this one, pyspark.test. Okay.
Oh.
Let me open one IDE. And once you submit this into the, so I was in the previous session, I was spinning up an EMR cluster, right? Where I was consoling, where I was trying to connect to the Hive console, and then I was showing the Hadoop commands and everything. So over there, when you log into that EMR console, okay, or the EMR putty, so over there you have to run this command. Once you run this command, you have to make sure that the pyspark.testpi is obviously there. Only then it will run. Once you run this command, then it will start running your job. Okay. So if I talk about this one, so this is one Spark application. This is one Pyspark code that I've written. Okay. So the thing is, I can run it over here. It will run in local. I will be mostly showing you all the examples in local. Okay, just to understand the code structure and everything. But at the end, when I'll be showing how to deploy, so that's like a one-step thing. So only then I will spin up an EMR cluster and I'll show you how to deploy the application. Okay, so over here in local, if you see in the master, I'm giving local 2. Now this 2 means the number of cores that I want this application or this code to use. Now I know I have around like 6 cores in my laptop. Okay, so obviously if I make something like 8 in that case, that's not possible. I can either do this star means use all the cores in my laptop. Otherwise, I will assign. So since I don't want this code to hog all the memories or to hog all the cores in my laptop, so that is why I'm providing only 2. 2 out of 6 cores will be used. Okay, so that's a different scenario. So the thing is, this is the pyspark.testpy, the model that I'm writing, and I have to run it into my yarn cluster. Okay, to do that, I'm using this command spark submit, and then I am giving this model. So this model I'm assuming will take 5 number of executor. It will take 5 gigabytes of RAM for each and every executor, and then driver memory of 1 gigabytes. And I want it run in master yarn. So this is what it means. Okay. Yeah. So I was talking about partitions. Okay. So suppose so basically over here, I'm reading 3 files. Okay. Yeah, index, info, and processed. Okay. So for each and every file, whenever I read a file in my Spark program, so that I say, so roughly around whatever the file size divided by the block size, that is the number of partitions will be used. Okay. So suppose I have total, say 100 partitions. How many executor I'm giving? Number 5. Okay, let me give small number 20. So I have 20 partitions. So I have one file I'm trying to process in Spark. And then in the Spark, once it reads the file, it is creating 20 partitions. So 20 partitions is equivalent to 20 tasks. So to parallelize the programs, so to parallelize the Spark application, what will happen in the class, 20 tasks will be spawned immediately. Okay. And this 20 tasks, for each and every task, there will be one single V course. Okay. Have I assigned executor course? No. So that is also one more thing that we do. Executors course, say 4. Right. So I have total how many cores in the cluster? 5 into 4, 20. If I talk about memory, it's 5 into 5, 25 GB. If I talk about cores, it has 5 into 4, 20. Okay. And these cores are nothing but in your laptop or computer. We have the Intel cores like octa-core, hecta-core, dual core. Okay. So that means how many cores that will be used. Right. So total, I have 20 cores and I have 20 tasks. So now each and every core will be utilized. Each and every task will be utilized by each and every core. So one core, one per one task. So, but what happens if I say have 80 tasks? Okay, and I'm saying that only one core can take only one task. So, at once, 20 core will be working upon 20 tasks, right? But what about the rest 60? So will the job fail? No. So what happens, Spark basically, it will process the first 20 tasks, and rest of the 60 tasks, they will be put on queue.
Okay.
Okay, so these 20 tasks will be processed. So once these 20 tasks are processed, they will be given back, they will be provided back to the worker node, and then the next 20 will come up. So after that, from 60, next 20 goes out, so the 40 tasks are remaining. All right. Then after this processing is done, then the next 20 will come up. So that's how in queue iterations, Spark will conduct all the tasks, carry out all the tasks using each and every V code. Okay.
Okay.
So, so this is the task, each and every task, as I say, how it is equivalent to the number of partition and how it is dependent on the file size that I'm reading. So second one is the stage. Okay, stage will be created, and stage is another process. How these are differentiated, I will come into that diagram. So stage will be created based on the white transformations. And white transformations is nothing but the shuffling that is happening inside my Spark application. Okay, so what is shuffling and what is white transformation? I will be writing my code. I will be putting some different transformations. Like I will be putting something like group by, I will be putting join, I'll be putting filter. In previous Spark context or RDD platform, there was one thing called the map. Okay, so in all the cases where there is the shuffling happening, only those are known as the white transformation. And the shuffling means where data will be moving across different nodes. Okay, so what does it mean? Is because basically I have. Do you have any idea how filter works or how group by join this works?
Yep.
Sorry, hello.
Yes, I know how they work, but not in Spark.
Okay, okay. So suppose there are two transformation. One is the filter, the another one is the group by. So filter is nothing but, suppose I have a file and there is a column. There's a column called salary. Okay, and I want to filter out only the salary which are greater than say 50,000.
Okay.
Okay, so what will happen in each and every node? So my data, so once Spark creates, so my data will be partitions, right? There is one partition, there is another partition, and so on. So, and along with all the columns, salary also will be partitioned across, right? So suppose this one has 10,000, this one has 20,000, this one has 60,000, this one has 70, this one also has a 20,000. Okay, and this one has 1 lakh, this one has again 10, another 10,000, 30,000, and then 80,000 and so on. Okay, so the thing is, each and every partition, this filter transform will go, and it will simply only get the ones that are required, that is greater than 50,000. Okay, so if there are 150,000, it will get from over there. If there are, suppose say there's 60,000, 70,000, there are two more than 50,000 salary, it will get over there. There's another filter. So this filter is happening in each and every partition. Okay, over here, whatever the salary in the third partition that is greater than 50,000, those are bringing up, and then in the resultant partition, it is accumulating. Over here, suppose there is a 60,000, there is 70,000, there is 1 lakh, whatever the salaries they were, more than 50,000 from these partitions to these partitions, they are being transferred. So over here also the number of partitions at the beginning, the before and after being the same. There were 3 partitions before, even after filter, there are 3 partitions. So there is no change of filter. So there's absolutely no shuffling. But suppose if I talk about, but suppose if a group by operation is happening, and again, these 3 partitions are there, and suppose there's a department. Okay, employee department, some of the are working in IT, or not department, basically occupation. Okay, some of them working in IT, some of them are like government employees, some of them are doing some entrepreneurship, like they are businessmen, and again IT and whatnot. Okay, so if I try to do a group by, group by occupation, and then dot count. Okay. So for each and every occupation, how much is the count? If I try to get that, then what will happen? It will first, this group by operation the group by operation will first get into all these partitions, and it will try to get the similar occupation into one partition or into different partition. Okay. So basically it is taking, suppose group by operation for IT, there will be one count. Okay. For government employee, there will be another count. For businessmen, there will be another count, and so on. So what will happen? It will go into different partitions. It will get the similar kind of, it will group all the occupation, then it will combine them to get the count. Okay. And once it does it, there will be 200, not going to 200, there will be n number of other partitions. Okay. So previously there was 3, now it will be, suppose say 5, 6 or whatever number of partitions, and it will store over here. Okay. So that's how it works. So there will be one IT. Okay. There will be another IT. There will be government employee. There will be businessman. There will be government again. There will be another IT. So that's how it works. So basically data is being taken from each and every partition, each and every task, and it is being distributed across all the other partitions. So this is one example. So this is how a white transformation, or this is how the shuffling happens. And for each and every shuffling, there will be one stage created. So the stages and tasks I will show you in Spark UI using the Databricks Community Edition. But for the moment, just know that whenever I'm calling this group by join operation, where it is required to get data from different partitions, then combine them in somehow. So that is when the shuffling happens. Okay. And there is one more thing to know about the, due to the shuffling, the default number of partition that will be created is 200. So even if I have 3 partition from the data is being read, even after that 200 number of partitions will be generated. But I don't need that, right? If I know my partition, my data can fit into 3 to 4 partitions, why do I need 200 partitions? It's going to take a lot of time, because each and every partition will be worked upon each and every core. And there will be, and suppose I have 10 cores and the number of partition is 200. So there will be 20 iterations, right, to finish up the job. Whereas if I have, say, only 10 partition, only one iteration, the job will be finished, right?
Correct.
So we can tweak that shuffle partition number. How to do that, I'll cover up in later sessions. So this is how basically the task and the stages work. Task is the one where each and every partition will be taking up each and every V core will be taking up each and every partition. Then the stage is happening due to the white transformation shuffling. And then coming to the parent hierarchy, that is the job. Okay. And job will be the utmost action that I trigger. So when I suppose I'm applying a lot of filter, group by join operations and everything. So until and unless I call upon a collect, or I call upon a show, or suppose I write the data frame into another file. So up until that, Spark won't trigger any action. It will only trigger action when I'm highlighting or I'm specifying all of this phenomena. That is the either collect, show, count, or say writing to data frame. Okay, so that is basically, so that is the idea of lazy evaluation of Spark. Okay, it kind of creates a DAG. So this DAG will be created. So suppose I'm reading a file. Okay, then I'm putting some filter. Okay, then I'm putting some group by. Then I'm joining the data. Okay, and then suppose I'm calling a count or show to see the data frame or check the count. So up until here, this will create a DAG. Okay, DAG is known as the direct acyclic graph. So this DAG will not be triggered. So when you read the file, when you filter the file, when you group by, when you join, if you don't put any count or show, this will take, this will be done in a moment. Okay, it won't take much of a time. But once you call the count or show, now it will try to process all the things that you have called upon. Okay, so that will take some time based upon the amount of data that you're trying to read. You'll see the Spark job is you'll see the Spark job is happening, and for each and every Spark job, you'll see the stages, task, and stages, task, and how it is basically hierarchy. So this is the execution. So once I create my Spark application, that is the .py file that my code has been written. So I will be reading some file, I will be writing to file, I will be putting some show and count. Okay, so based upon that, the jobs will be created for each and every job. If there is one stage, there is any shuffling happening, in that case, the stage will be created. And for each and every stages, there will be task. Okay, so the thing is, even if I call the group by operation and then the shuffle is happening, so over there, so this group by will try to get each and every data from each and every partition, right? So there will be also a task, but at the end of the time, it is not kind of like inflicting only one single partition, but it is trying to process all the partitions in the cluster. So it is moving to different partitions. So that is why the shuffling is happening. That is why there will be multiple tasks in one stage, and that's how the whole execution is breaking down.
Okay.
All right. So enough of the theory. So let's get on some hands-on. So to practice, the simplest way is create an account in the Databricks. You can use your Google account to create an account in the Databricks Community Edition. And all you have to do is just create a dummy cluster, and then you can write your Spark code. You can write your Spark code. You can write your Hive queries. You can write your be it Scala, Python, anything. So first and foremost over here, you see this new button. From here, I can create a notebook. I can create a notebook. I can create a table or cluster, anything. So each and every notebook, anything, it has to be attached to a cluster. If the cluster is not up and running, in that case, notebook will also, the notebook will be created, but it won't be able to process anything. So let me create a cluster first. You can also create it from over here in the compute section.
Okay.
Let's name it my cluster. So you can see with the free account, only free 15 GB of memory will be assigned to your cluster. So that is quite okay. I mean, it's not that I'm going to be using for heavy task. So let's do create compute. You can also try running the script in PyCharm as well, but you have to set up some environment. Like you have to have Java home, Hadoop home. I'll show you those things, and then only your Pyspark will be running. You have to install Pyspark as well in your local laptop. But this is the easiest one, where you just have to create an account and start using it. Let me use this notebook. Previously, in the Hive session, probably I showed you there was one social circle table, right? Where I was trying to create impart the schema on top of it using the partition table. So I'm using the same file over here. So before running anything, you have to attach, this is the notebook, and you have to attach this notebook to a cluster. So currently my cluster is the one that should be creating. Okay, let me explain the code for the moment. So I have uploaded one file called fakefriends.csv, okay, into my data catalog or into my DBFS file store. How to do that? You'll go to catalog. There's the database table. So there are two API. One is the database table, much like the Hive table, you can use it. And the other one is the file storage. So in the file storage, so I have uploaded my fakefriends.csv over here. Okay. Huh. So I will simply go to upload and then draw files. So this will take it to my Windows Explorer. Okay, so from here, I can select any file that I want, and then it will upload over here. So once the uploading is done, what I have to do is just copy the path from here to process the file or read the file. Do copy path. There would be two ones, Spark API, File API. Choose the File API format. Choose the File API format, copy, close this one, and put it over here. It's already there. I just showed you how to copy that one. So my file is residing over this file store. I want to read this one. So see this one. To read any file in Spark, the spark.read is the most primary thing. Okay, spark.read will have to be there. This one is optional. I'm enforcing the schema for the moment. I will take it out. Then the format of the file I'm trying to read. So in this case, I'm trying to read a CSV file, right? Suppose I was trying to write a Parquet file. In that case, I will be putting Parquet like this. If it's an ORC file, then I will be putting ORC like this. Okay. So my one is CSV. So I'm putting CSV, then the file location. And then if my CSV has a header, okay, and I want that the first row or the first record is a header in that, and I want that as a header in my data frame as well. In that case, I'll be putting header equals to true. There's another way I can put it. So this is the Pyspark way. If you're using Scala or even in Pyspark also, there is one term called option. Then header. So this is another way of putting the header equals to true. Okay, so this will only be applicable when you're using Scala. In Scala, you cannot put over here and say header equals to true. All right. And so by default, if I run this one, all the columns, ID, name, age, number of friends, so they will be inferred as only string. Okay, let me try this one. I will print the schema. Right. So all of them are string because by default CSV doesn't handle the schema very well. Okay. But there is an option. So there is two ways I can enforce the schema or I can infer the schema. To enforce the schema, this is the schema that I've written. And I know that the field names are ID, name, age, and number of friends. So I just have to create a struct type of the struct fields for each and every case. ID will be of integer type, name will be of string type, age will be of integer type, and so on. So over here, you can see there's a discrepancy between this schema and that schema that I've put. There's another way we can infer the schema, not using the one that I've just created. So that is infer schema equals to 2. So for that, so let's see how this works.
Could you
Okay,
maybe
sorry.
font size a bit? Yeah, this works.
All right. This is okay?
Yep, yep.
Right. For this one as well, I've put header equals to true. It's not getting it. Let me put it over here. Because this file doesn't have any header. Okay, I think this one doesn't have any header, so that is why it is not showing. Okay, so that is the reason I had to enforce the schema. Otherwise, if I had any header file, I would have shown you. So there's one thing is called infer schema. With the infer schema as well, so what will happen? It will automatically analyze the schema of the data. So if it is 33, these are some numeric values. In that case, that will come as an integer. Okay, but in most wide cases, in most of the cases in the projects, we enforce the schema, whatever it is, whatever we know that how the data type would look like. So in that case, we would be using the schema only. So putting the schema that I have defined over here. Now the schema has been enforced. So this is one print schema to get to see the schema, how it looks like. Okay, then if I want to see the data frame, there is one method called show. And in the show, by default, if you run it, it will show only 20 rows. So it's only showing top 20 rows. But if you want, you can customize that. You can simply put 10. I don't need that much. And there's another attribute to it that's called truncate. I can put truncate equals to false. So you won't see much of a difference over here, but in some cases in data frames, what happens is that there is a value that is exceeding this space. So in that case, you'll see like dot 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 to be continued, some sort of thing. Okay. So in order to deal with that, if you put truncate equals to false, so it will show all the data frame with all the column values intact. It won't try to truncate anything. Okay. So that is why truncate equals to false. Even over here in the show command, you can simply put false, and by default the second argument is truncate, so that works in a way. So this is basically how to read a data frame, how to read a file, create a data frame out of it, and then you can use the show or the print schema to get the schema or to see the data frame, what is the data. Okay, if there is any data that is in Hive, that's also readable. Let me show you that. I hope the cluster is still running. So I don't have any table at the moment. Database, okay. Yeah, I think I do have one. No, I don't. So let me go to the workspace. Without while reading the file value part and the cost file form man form to ORC.